we're going to look at something interesting, tritium. There are measurements of tritium at the WTC. Why is it important? And apparent transmutation. First of all, there's some of the aluminum found at the WTC. It's just eaten out like Swiss cheese. That's a regular piece. And the material properties seem altered slightly. Zinc, this is the normal sample, and then that's the affected sample. That's what caused him to start wanting to take the building apart. It was ongoing. This is the ratio of the affected dust to the background levels. 3,500 times, approximately, more zinc than normal. John Hutchison's sample. You have a whole lot of, this is just relative measurements, don't look at the absolute values, but in this sample of brass, the unaffected area had a whole lot more copper than zinc, but in the affected region, about equal. Let's think, if that's heat that's doing it, zinc boils before copper melts. So that doesn't explain it. The first thing to vaporize would be zinc. But zinc is still there. It's the copper that's decreased. This is from...
At Texas A&M, a group led by Professor John Bockris, who is widely regarded as one of the world's greatest electrochemists, reported finding the hydrogen isotope tritium, a key signature that some unusual nuclear reaction was going on.
The first thing was this thing called tritium, which was a sub-form of hydrogen which should not exist except in extremely tiny quantities. We found that by working these cells of Fleischmann and Pons containing lithium hydroxide and deuterium oxide, that we could produce this tritium in great abundance, let's say at 10,000 times more than it ought to be there, as it were. And let me stress that we couldn't do it every time, but about one result in 5 or one result in 4, and eventually we worked up to 2 results out of 3. We could produce tritium. That was the first thing, and in a way it was the first clear proof of the phenomenon.
And but the most important and unbelievable phenomenon at that time was the observation of tritium.
Back at Texas A&M, Bockris's group found themselves under attack. Science magazine writer Gary Tobbs wrote a stinging article that insinuated that someone in the group had spiked the samples with tritium. Although unfounded and eventually proved untrue, the allegation effectively dampened Bockris's remarkable claims.
But I think the main part was that I had done work which was against the paradigm, and that was what they were really upset about. People had laughed at it and said, "What the heck are you doing, trying to disprove the laws of nuclear physics?" And of course, that's exactly what we were doing, and succeeding, you see.
The tritium work was the first indication to me that there was a reality. And then Claytor at Los Alamos also got positive results, and so did Howard Menlove. And they're people that I respect and could talk to personally. It became fairly clear that there was a very strange phenomena occurring here.
There are also, in similar experiments sometimes, and rather dissimilar experiments sometimes, evidence of an anomalous nuclear process.
However, it is conceivable that there may be a process even more powerful than nuclear reaction that physics does not yet understand. That is the mystery of cold fusion. Yet as early as 1992, cold fusion experimenters began reporting unusual appearances of trace amounts of different metals such as copper, silver, chromium, and zinc when examining their spent cells. Rechecking for possible contamination, scientists like Bockris and Miley confirmed that indeed new metals and isotopes were being formed, transmuted, during the process which produces excess heat.
Kevin Wolf made many measurements of tritium. Then he got some even more astonishing results as early as 92, which were these transmutational results, the metal forming another metal inside the electrode, you see, which was super anti-paradigm. There's that dreadful word alchemy, which we mustn't use, but it was a form of that in a way. It was creating new metals, you see.
We see transmutation phenomena. We see helium-4 production. We see a range of methods of getting the excess heat. The writing is on the wall. The fossil fuel age is about to end.
The sword of this panel's condemnation struck with speed and brutality, ignoring the facts in a blind rush to judgment.
Hot fusion physics people have been very vigorous in their denunciation of this being called fusion.
Right away, reports came in of excess heat, much too large to be from any chemical reaction. Laboratories from Texas to India confirmed the presence of tritium, a vital determining feature of a nuclear reaction.
Within 2 or 3 weeks, we got the first results, and several groups started saying, yes, we are seeing excess heat, but the most important and unbelievable phenomenon at that time was the observation of tritium.
This was a discovery perhaps as significant as the Wright brothers' first flight at Kitty Hawk.
There are also, in similar experiments, evidence of an anomalous nuclear process.
In the free-for-all that followed the cold fusion announcement, hot fusion proponents drew the specious conclusion that cold fusion must work like hot fusion. If Pons and Fleischmann are alive, they contended, then their results must be faulty, since the neutron radiation from the fusion reaction would surely have killed them. They refused to consider that another form of the same process might be at work. In the years that have followed, the cold fusion process has repeatedly produced not only heat energy, but also nuclear byproducts such as tritium and the ash from a nuclear reaction, that all-important indicator of nuclear fusion, helium.
It's clearly not possible to produce helium from a chemical process. The only possibility that remains is that the helium is produced by a nuclear process. If the helium is produced by a nuclear process, then necessarily there will be an associated release of heat. Having seen the effect with my own eyes, the claims from a few that this is impossible, inconsistent with all known laws of nuclear physics, these suggestions are in fact irrelevant.
Look at the data. The data shows it. Now, why am I focusing so much on the tritium? It's evidence of some kind of nuclear process, but without the ionizing radiation, you kind of wonder, is it really, This is from the World Trade Center, some samples of airborne dust. Now, if we looked at it, the abundance, this is the abundance of it, as a function of the melting temperatures or the boiling temperatures, you would expect it to go from, the highest being dark blue to red on the right. There's no pattern to it. There's a low abundance of this easily, low boiling point and low boiling point, but the high boiling point in between is, I don't know what to make of this. It doesn't look like it's patterned after the boiling point. There's something else in it. But most of all, there's an organic component to this. You can't have high temperature vaporization of something with organic component. Here we go. This is the big one. This is a logarithmic chart. The amount here is the amount of tritium you get from a nuclear power plant that's leaking and contaminating the water. Tritium has about a 12.5-year half-life. There's been nuclear testing in the atmosphere, bombs. That's what this is, beginning at 1963 and ending in 1990. You can see it's decreased over time. It kind of goes away. Current Great Lakes measurements are here. This is from, quote, cold fusion. Low energy nuclear reactions is a better term for it. You can call it cold fusion right now. That's group D. What is this? This is the World Trade Center measurements. Definitely above background levels. Indicative of some kind of nuclear process. Now, they're doing this in, little beaker with some electrodes in it. Imagine if you got a fire hose and watered it down and rained on it, diluted it. Heck, maybe you come up with that. Or it doesn't necessarily have to be in liquid. There's something else like that. That it seems to have a lot of similarities, the transmutation, but the tritium shows there's some kind of a nuclear process going on without the ionizing radiation. A lot of people say, nukes were used, mini nukes, pocket nukes, maxi nukes, whatever. If nukes were used, you kind of think they'd be picked up around the world, because could they have kept Chernobyl a secret? And it's measured all around the planet. Relative to C is the amount of tritium measured at the World Trade Center. What you get with LENR or cold fusion is about 50 times that. 1/50th is what you get with background levels. So definitely the World Trade Center measurements are significantly above background levels. Leaky nuke plants, 18,000 times what was measured at the World Trade Center. So relative measurements, this seems to be somewhat in the right ballpark.